everyone, welcome to Coding Made Easy. Today we are going to discuss the problem subsets. Given an integer array nums of unique elements, return all possible subsets. The solution must not contain any duplicate subsets and return the solution in any order. So the given example is 1, 2, 3. The subsets of possible subsets of 1, 2, 3 is empty 1, 2, 1, 2, 3, 1, 3, 2, 3, and 1, 2, 3. The total number of elements in this list is 8. So if you have 3 elements, we'll have 2 to the 3, 8 elements in the output. So let's dive into the solution. So now let's break down the given question into smaller answers, smaller question, and see. If the input is empty, the output is a set of empty set. If it's 1, we see it's empty and 1. And if it's 1, 2, it's empty 1, 2, 1, 2. So if we see at each level, the number of elements is increasing by double. So 1, 2, 4, and 8. And see if there is a pattern. So the pattern is the empty, and due to the introduction, so if we compare from empty to 1, the diff is basically you copy the empty and then you add 1 to it. And see if we see the example of 1, 2, you copy the answer from below and then you kind of duplicate this and add 2 to it. So due to the introduction of 2, we got 2 more elements in the answer and we added 2 to it. So now how can we think to come up with a solution of 1, 2, 3 using the solution of 1, 2? So basically we take this part of the solution, copy it above, and then duplicate this empty 1, 2, 1, 2, and to each element add 3 to it. So that is our answer. So let's try to code that. So we can create a wrapper function so that we can pass the right parameter. Subsets. So this will return a list of list. Okay. So now what is the base case? If index is length of nums, then we are kind of done. It's kind of an empty set because we have reached index is length of nums, so there is no more elements to see. So we return an empty list. Okay, so what is the next thing? Let's get the answer for subproblem. So list, let's call this width. So basically this call is getting the answer for the smaller problem. So for example, for when we are trying to solve 1, 2, 3, this output is the subarrays. This is the sub answer, which we are calling as list subarray. So now this list subarray contains that list. So how do we, using this answer, how do we construct the final solution? So we can create a copy of this list. So we can use the deep copy method, which is available. So now we got the copy. Then for each element in the copy, append the list, the nums of index. So what is nums of index? Nums of index is the new element compared to the smaller sum problem. So nums of index is 3. So in that replica, so this is the copy. So in this list of elements, for each element, go and add 3. That's what we are going to do for list in this copy. So now we have added, and we'll just return. So we concatenate these two lists and return that list. So that should be it. Oh, invalid syntax. Oh, this is not really needed. Yeah, so that worked. Okay, so that is the solution. Um, so what is the time complexity and space complexity for this? So let's go back to the drawing board. So time complexity. So if we want to solve for 1, 2, 3, the number of recursion levels or number of times we are going to compute the solution is just n. So for 3 elements, we'll just go three layers deep. So time complexity is n. Space complexity, if you have n elements, we are going to always store 2 to the n elements in the array because the output requires returning all the elements um, in the power set. So the space complexity is 2 to the n. So that's it. Thank you for watching. See you in next video. Bye.